This next unit will be talking about quadrilaterals and coordinate algebra. This particular unit in PowerPoint will cover topics 1 through 4 for the topics you will see on Edgenuity. So a quadrilateral is a polygon with 4 connected sides. The sum of the interior angles is 360 degrees. So what that means is a polygon is going to be any figure with connected sides, but a quadrilateral in particular will have 4 of them. So 1, 2, 3, 4. These generally should be straight lines, and they should be perfectly connected. So each of these angles, if you were to add them all together, should equal 360 degrees. So A, B, C, and D. If you added angle A plus angle B plus angle C plus angle D, it should equal 360 degrees. It's similar to how all 3 angles in a triangle equal 180. We have an additional set of degrees now that we're adding to our figure. Some common quadrilaterals that you'll see have some different names that we'll be seeing throughout this unit. The first one we'll be talking about is a parallelogram. So opposite sides of a parallelogram are congruent and parallel. So that means that this side is congruent to this side. This one is congruent to this one, because they're opposite sides. So it means they're going to be congruent to the opposite figure. It also means now this side is parallel to this side. Remember, these little arrow tick marks mean parallel. This side is parallel to this side. Opposite angles are also going to be congruent. So that means this angle is congruent to this angle. This one is congruent to this one. The diagonals bisect each other, which means this angle and this side. So these two sides should be congruent, and these two sides are congruent. All right. Put a little circle around them so you know they're different from these two sides. The last thing you need to know is that adjacent angles are supplementary. So that means two angles that are next to each other if you went around in a clockwise fashion. So this angle and this angle are supplementary. Supplementary, just a reminder, means that they sum up to 180 degrees. The next figure we will be talking about is a rhombus. A rhombus is also called a parallelogram, so it has all the features we just talked about for parallelograms, but it also has a couple additional features. So opposite sides are congruent and parallel. So just like we talked about with the parallelogram, these are going to be congruent and parallel. And we also will talk about how the opposite angles are congruent. So this angle is congruent to this one, congruent and congruent. An additional feature that you need to add in are that the diagonals are perpendicular bisectors. What that means is that these two diagonals, they meet at a right angle, and that these are congruent all the way around. These two are congruent because they're being bisected, and these two are congruent because they're being bisected. The most important thing is that we have a 90-degree angle being formed. The next shapes that you will see, and you are probably most familiar with, are rectangles. So rectangles are also considered a parallelogram. So this means that it has all the features that parallelograms have and a few additional features. So opposite sides congruent and parallel. And all of the angles in the entire figure are congruent, not just opposite. And that means since they're all congruent to each other, they're going to measure up to be 90 degrees. Diagonals are congruent and they bisect each other. So bisecting. And they are not perpendicular bisectors. Cross that out. That was a mistake. All right, so all you need to know is that they bisect each other. All right, so squares are another figure we need to take note of. Squares have all sides congruent. So that means each and every one of these sides will be the same measure. So if this is 10, this is also 10, 10, and 10. We know the opposite sides will be parallel. So that side is parallel to that one. All angles are also congruent, so just like a square. So these are 90 degrees. Diagonals are perpendicular bisectors. So that means we form a right angle and that these are congruent. All squares are also called parallelograms, rhombi, and rectangles. So that means that all the features we talked about for these three quadrilaterals also apply to a square. These features will be important when we're talking later about how to identify these different figures. So trapezoids have exactly one pair of parallel sides. Ooh. That means this one and this one are not parallel because they will eventually cross if these lines continue on forever. So our exactly one pair would be this set right here. Does not mean that they're congruent if it's a trapezoid. You have to look for other specific features. An isosceles trapezoid, on the other hand, is where we will see a set of congruent sides. So it has the features of the original trapezoid. It has exactly one pair of parallel sides. And then the non-parallel sides are going to be congruent. So this side is congruent to the side. The base angles, so the angles at the bottoms and the tops will be congruent. So these two right here are considered base angles, and these two at the top are also considered base angles and will be congruent to each other. One last feature that the diagonals will be congruent. So this diagonal is congruent to that diagonal. The last quadrilateral we will be talking about in this unit is a kite. The main thing you need to know about kites are that adjacent sides are going to be congruent. So that means the sides that are directly next to each other. So these two sides are congruent, and these two sides are congruent. The last thing you need to know about a kite are that one of the diagonals is the perpendicular bisector of each other. So this is perpendicularly bisected, meaning that these four angles are all right angles. And then the shorter side is always going to be the angle that is the side that is bisected. So this side right here is being bisected. So this section is congruent to that section. Okay, so let's go ahead and use some of these properties to help us solve different things. So if this is a rectangle, we know the opposite sides are congruent. So this side right here should be congruent to this other side. So 18 should equal 10 plus 2x. If you go ahead and solve for x, that means getting x completely by itself, we will be able to figure out that value. So 8 equals 2x, and when you divide it by 2, 4 equals x. If you were to go ahead and figure out the other side of the figure, again, because it's a rectangle, we know the opposite sides are congruent. So we have 10 equals 2y plus 4. We're going to want to get y by itself, so that means removing anything from the same side that y is on that's preventing it from being by itself. Here we divide by a 2, because I will undo this, and y will be by itself, so 3 equals y. We go back and double check, do we answer the question? What are the values of x and y? X is 4 and y is 3, so we did go ahead and answer that. So, given the figure is a kite, fill in the missing measurements for each side. Knowing that this is a kite, if we were to flip back to that first page, we would be able to see that adjacent sides are congruent. So this side is congruent to this side. So again, kind of like what we did with the rectangle, we could go ahead and set this 5 equal to this 2x plus 1. So 5 equals 2x plus 1. Go ahead and subtract your 1 and finish solving for x. So in the end, you'll have 2 equals x. So x equals 2. This side is also a 5. Now that we have that this is a 5, and we have that x equals 2, we can go ahead and plug this 2 up into this equation in order to figure out what each of these sides are. So 3 times 2 instead of 5, or instead of x, we're plugging in that 2 plus 5. 3 times 2, we gotta use our order of operations, so we want to multiply first. Will give us 6 plus 5, so we should end up with 11 in the end. So let's go ahead and label this side an 11. Does a double check our work? Let's also go ahead and plug a 2 in for this x to make sure that these sides are congruent. So 5 times 2 plus 1 will give us 10 plus 1, which gives us 11. So each of these sides is 11, and each of these is 5. We see that our adjacent sides are congruent and that we do in fact have a kite. So in this next figure, we know that EFGH is a right trapezoid. We want to find the angle measure of E. In order to figure out that angle measure, we have to go ahead and find out what x is. We know that this angle, because it is a right trapezoid, is going to measure 90 degrees. Because a trapezoid is also a quadrilateral, we know that the total measure of all 4 angles will be 360. So now that 360 will equal that 90 degrees plus that 9x plus that 14x plus 4x. We want to go ahead and combine like terms in order to figure out what x is. So 9x plus 14x plus 4x gives us 27x. All right. The next step is we want to subtract 90 in order to work on getting x by itself. We'll have 270 equals 27x. You divide by 27, we'll have 10 equals x. We gotta go back. We did solve for x, but we gotta make sure we're answering the original question. The original question is asking for the angle measure of angle E. So angle E says that it is 9x. So instead of x, we can go ahead and plug in that 10, and we'll get 90 degrees for angle E. All right, so angle E is also a right angle. This next section, we'll be talking a little bit more specifically about the properties of parallelograms. We'll be using these properties to solve for different angles and sides. Just to review, opposite sides are congruent and parallel. Opposite angles are congruent. Diagonals bisect each other, and adjacent angles are complementary. You already have this section written down on the very first page of your packet. So, what do we know about the angles of parallelograms? If you look at those notes that we took, we know that opposite angles are congruent. And adjacent angles are supplementary. So in this figure, we have two angles, A and C, and they are both given two different expressions in order to define their angle measure. But what we do know are that these two angles are going to be equal because they are opposite angles. So we can go ahead and set them equal in order to solve for y, in order to figure out how much each angle is worth. So we have variables on both sides of the equation. What I do is I always move the smaller variable to the other side. Helps prevent getting negative numbers. We have 27 equals 2y minus 3. Add 3 to both sides. You'll have 30 equals 2y. You divide by 2, and y equals 15. We still need to go back and get angle C. So angle C, we just want to plug in that 15. So we have 3 times 15 plus 27. I'll give you 45 plus 27. And 45 plus 27 should give you 72 degrees. Okay, so angle C is 72 degrees. Now we want to get angle B. We notice angle B are angles that are directly next to each other in the figure. This means that they are adjacent. Because they are adjacent, angle B and angle C are supplementary. That means angle B plus angle C equals 180 degrees. Using a little bit of substitution, we know that angle C is 72 degrees. So we can plug in a 72 instead of angle C. Subtract 72. And angle B equals 108 degrees. Okay? So, what do we know about the diagonals of parallelograms? We know that they bisect each other. So, in this question, when we are solving for the measure of segment BE, we just want this segment. But currently, this segment has some variables involved in it. What's going to help us is knowing that this segment is congruent to this segment because it is being bisected. So 2x plus 9 will equal 3x minus 21. Now we just need to go ahead and solve for x. So 9 equals x minus 21. Add your 21 to the other side, and you'll have 30 equaling x. Now that we know what x is, we can go ahead and plug it back into the expression for BE. So we know that segment BE equals 3x minus 21. If we plug in 30 for x, we'll have that 3 equals 30 minus 21. So 90 minus 21 will give us 69. So the length of segment segment BE is 69 units. The next figure that we are dealing with is again a parallelogram. We want to find the measures of opposite sides. We know that opposite sides are congruent. That means if I take this side and set it equal to this side, I should be able to solve for y because I know that these two opposite sides are going to be congruent. So I have 4y minus 3 equals 37 plus 3. You add 3 to both sides. 4y equals 40. When you divide by 4, we have that y equals 10. That actually solves for question B. I did this a little bit backwards, but that's okay. We're now to go and solve for x, and 3x minus 9 has to be equal to 42 because we have a parallelogram. So 3x minus 9 will equal 42. I'll need to add my 9 to both sides. 3x equals 51. When you divide by 3, you should get that x equals 17. So now we have successfully solved for x and y using the properties of parallelograms. The next topic we'll be talking about within this section will be how to prove a quadrilateral is a parallelogram. So we'll be using the different properties of parallelograms in order to prove that these quadrilaterals are in fact parallelograms. So in order to say that this quadrilateral is a parallelogram, we need to talk about the properties. If you were to flip back on your first page, what is a property that you know we would be able to relate these two sides with to make this a parallelogram? If you look, you should see that the diagonals bisect each other. So 2x plus 5 should be equal to 3x plus 2. So go ahead and write down that diagonals bisect each other. All right, so in order for this to be a parallelogram, let's go ahead and solve and see what x needs to be. So as we said, for this to be a parallelogram, those two segments need to be congruent. So 2x plus 5 has to equal 3x plus 2. Let's go ahead and solve and see what that value of x would give us. You should end up with x equals 3 in the end. If we were to plug that in, we would see that both of those segments would be congruent, giving us a parallelogram. So in order for a quadrilateral to be a parallelogram, what do we need to know about the sides? Again, if you look back at that very first page in your packet, under our requirements for parallelograms, if you look and see what we need to know about the sides, we would need to know that the sides, opposite sides, are congruent. So that would mean, in order for this figure to be a parallelogram, let's go ahead and solve for x in order to find that out. So if I have 10 equals x plus 2, these are opposite sides. Let's see what x is. 10 equals x plus 2. 10, once you subtract 2, you'll get 8 equals x. So the side will also be a 10 if you were to plug that in. And this other side, let's just go ahead and double check what this side should be. So I plug in my x, I have 2 times 8 minus 3. That will give us 16 minus 3, which will give us 13. Over on this side, if we were to plug it in as well, we'll have 8 plus 5, which will also give us 13, proving that in fact this is a parallelogram because our opposite sides are equal. Next, we're just being given a simple question. Is this figure a parallelogram? If you were to look back at the first page again, I know we keep flipping back and forth, look and see what our requirements are for a figure to be a parallelogram. You would see that both sets of opposite sides would need to be parallel. So right now, we have the makings of what something could be a parallelogram, but we don't know for sure. So right now, we are missing information. In order for this to be a parallelogram, we would need to know that WX is parallel to ZY, and we would need to know that WX is congruent to ZY. So we need to know parallel, and we would need to know congruency in order to prove that this is a parallelogram. Our next figure, ABCD, is a perimeter, has a perimeter of 46 inches. So that means if we were to add all of the sides together, so AB plus AD plus DC plus BC should equal 46 inches. Right now, we know AB and DC are these two measurements, 8x minus 5 and 3x plus 10. Because this is a parallelogram, I know that 8x minus 5 is equal to 3x plus 10. So let's go ahead and figure that out. So if I were to go ahead and combine my like terms, I have 8x equals 3x plus 15. I subtract my 3x, I have 5x equals 15. So x equals 5 after you divide. Sorry, x should equal 3. So x equals 3 after you divide by 5. If we were to plug that 3 back in, we would get 3 times 3 plus 10. 9 plus 10. That'll give you 19 for the measure of DC and for the measure of AB, because we know that these two sides must be congruent. So if I were to go back to my equation, I cross off AB, I could fill in a 19, and I can go ahead and cross off DC and fill in a 19. Now we're almost done. In order to figure out how long BC and AD are, I need to do a little algebra here. So as we talked about, AD and BC should be congruent. I'm going to say that this is Y. So instead of BC, I'm going to write Y, and instead of AD, I'm going to write Y. Just to make things a little bit simpler and easier to read. If I add all of this up, I end up with 38 plus 2Y equals 46. After I subtract 38 from both sides, I end up with 2Y equals 8. Divided by 2, I have Y equals 4. So the final length of my sides in my figure will be 4 for AD and for BC. So BC, if we look back at our original question, is equal to 4. This next figure, in order to prove that it is a square, so this is the last topic we'll be talking about, special types of parallelograms. There are 4 special types of parallelograms, and it's rhombus, rectangles, and squares. And there are different properties if you look back at that front page that they all have on top of being a parallelogram. So in order to prove that this is a square, we would need to know that WX and YZ are congruent. And that is because all sides in a square are congruent. So in order to figure out the length of each side, let's go ahead and set these equal. So 2m plus 4 equals m plus 6. Go ahead and combine your like terms. You get m plus 4 equals 6. Subtract your 4. You get m equals 2. So if I were to plug that back in, 2 plus 6, this entire side is 8. That means each side of the figure is 8 because it is a square, meaning that all sides are congruent. In order to prove that this parallelogram is a rhombus, if you look back at your properties of rhombi back on the first page, we would know that each diagonal is a perpendicular creates a perpendicular angle. So I would need to know that 3x minus 12 equals 90 degrees. So angle AEB equals 90 degrees. So in order to figure out that value, I would need to write 90 equals 3x minus 12. So you go ahead and add 12 to both sides. You get 102 equals 3x. When you divide this by 3, you should end up getting 34 equals x. Double check if that is what the question was asking for. What is the value of x? We found it, it's 34, and you are good to move on. This next one, we are again dealing with a rhombus, and we need to find the value of a. So we got a few extra steps mixed in now. So we know that this angle here is 30 degrees. Because it is a rhombus, we know that this angle here is also 30 degrees. We know also, because it is a rhombus, this is 90 degrees. So this figure in here that I'm going to outline in blue is what we know as a triangle. Triangles have a measure of 180 degrees. So I know that that 30 degrees plus 90 plus a will equal 180 degrees. So 30 plus 90 will give me 120 plus a equal 180. Once you subtract 120, you'll find that a equals 60 degrees. The last part you then need to figure out is the value of x. So this is where we want to talk about what you learned in your previous unit about special triangles. This is a 30, 60, 90 triangle. All right. We have a 90-degree angle here. If I were to rewrite this, you have at the bottom, so this little angle corresponds to this one. You have your 60 degrees, and up at the top we have 30. This short side here, we have is 2, and we have 4. In a special triangle, such as this one, we know that we have some ratios and relationships between the sides. So our shortest side is always x, our longest side is always 2x, and this side is always x root 3. So if x is 2, I know if I plug in a 2 here, I'll be able to have that side. So the value of this side is 2 root 3. This is the last problem we'll be dealing with for this unit, and we need to determine whether the following parallelogram is a rectangle. So in order to know if a figure is a rectangle, we need to know a couple different things. We need to know the opposite sides are congruent, which we can see that they are. We need to see that they are parallel, which right now they look that they are, but we can't be sure. And we need to know that we have right angles in the corner. In order to figure out if this is truly a rectangle, we need to do some trigonometry to figure out if this angle here is truly 90 degrees. So a couple ways that we can go ahead and do that would be to set up some of our right triangle trigonometry, which you learned in the first unit. So if we were to pick two sides, let's call this angle A that we're trying to solve for. So angle A, in theory, if this were a right angle, this up here would be our hypotenuse. And one of these sides down here would be our adjacent side. So hypotenuse and adjacent, or if we wanted to solve here, we could use hypotenuse and adjacent, hypotenuse and our opposite. So you can go ahead and set up some trigonometric ratios in order to figure out if this is truly going to be a right triangle. So what you need to go ahead and then do would be to pick one of those ratios. I'm going to start with maybe trying to solve for this angle first. If this is truly a right triangle, then I should be able to say that the cosine opposite of 20 over 28 will give me angle x. I would also be able to say that this angle here, I'm going to call it y, I could use sine and say that 20 over 28 will give me y. And then these two, along with a, will give me 180 degrees. So if you were to plug these into your calculator, give me a second, I'll calculate that out too.